The Cafferty Group, technical service advisors with offices located in Nebraska, Iowa, Kansas, and Colorado, presents Essential HVAC Principles, Proper Refrigerant Recovery. All recovery, recycling, and reclaiming equipment must meet all industry and local standards. Current version of AHRI 740. System recovery. Things to consider. What's the purpose of the recovery? Is it a leak in the system? Is it possible to isolate the refrigerant within the system? If yes, then minimal recovery is required. If no, then full recovery is required. Is it component failure? Depending on the component, if isolation within the system is possible, it would minimize the amount of recovery required. If it's because of a compressor motor burnout, then additional procedures are required. Note: recovering to less than atmospheric pressure will draw moisture and non-condensables into the system. Note: when recovering refrigerant from systems that use water-cooled condensers or water-side evaporators, water flow must be maintained or the water must be drained to avoid freezing and bursting the tubes. Disposable refrigerant cylinder. DOT regulated. DOT 39. May not be refilled. It's a very expensive fine for refilling. Disable empty DOT 39 cylinders. Recover any remaining refrigerant from the cylinder. Open the valve and disable by drilling a hole or puncturing the cylinder to ensure that it cannot be reused. Then dispose of properly. Gauges. Rebuild the gauges periodically. Use short hoses. Some recovery units have gauges installed. Gauges and hoses should seal well, should hold pressure, and a 4-valve manifold minimizes hose and manifold purging. Self-sealing hoses will minimize hose purging. They will minimize emissions when connecting and when disconnecting. Schrader tools. Here's an example of a Schrader core replacement tool and a recovery evacuation core remover. Brass and steel caps on systems and cylinders. Keep tight with good seals installed. Definitions. A CFC is a fully halogenated, no hydrogen remaining, refrigerant containing chlorine, fluorine, and carbon atoms. An HCFC is a partially halogenated refrigerant containing fluorine, chlorine, carbon, and hydrogen atoms. An HFC is a partially halogenated refrigerant containing fluorine, carbon, and hydrogen atoms. And a halogen containing one or more halogens, fluorine, chlorine, bromine, iodine, or acetine, replacing some of the hydrogen atoms. Recovery. The act of removing refrigerant from the refrigeration system to minimize losses to the atmosphere. Recycle. That is the act of cleaning recovered refrigerant for use in the same customer's equipment. And reclaim. That is the act of reprocessing the refrigerant and returning it to ARI 700 purity standards. Recovery cylinders must meet the DOT specifications for compressed gases. They are available in various sizes, in portable tanks at 15, 30, 50, 100, 250, or 500-pound tanks. In non-portable, there is the 1/2-ton 1,000-pound tank and a 1-ton 2,000-pound tank. They must be labeled properly. And DOT 39 cylinders are non-returnable, non-refillable, and may not be used for recovery. Cylinder components. Not all cylinders will have every component shown. Liquid valve, vapor valve, non-condensables bleed port, safety relief valve, and a micro-electrical switch to cut off the pump when the tank is 80% full. Here's an example of the internal 80% full float switch. It shuts off the recovery unit to prevent overfilling the cylinder. This is a typical valve. Red is typically the liquid valve with a dip tube. Blue is typically the vapor valve. Colors may change per manufacturer. And here is a full view of the typical valve showing the internal liquid dip tube. Cylinder nomenclature. DOT, Department of Transportation. 4BA is the DOT specifications. 400 is a service pressure. WC 47.6 is the water capacity in pounds. TW 28 is the tare weight or empty weight of the bottle. 6-92 is the date of manufacture. FA 123497 is a manufacturer's serial number. You will see all of these things stamped into the tank. You will also see a retest stamp that shows the retester and the date of the retest. Cylinder nomenclature breakdown. DOT is the Department of Transportation. 4BA is the manufacturing specifications according to the DOT. Other cylinders may be used. See Specification 49 CFR. 400 is the service pressure. This is the maximum pressure that the cylinder should see. The minimum pressure, according to ARI guidelines, should be 260 psi. WC 47.6 is the water capacity in pounds of water. This is how much water this cylinder will hold if filled to 100% capacity. All cylinders are rated in water capacity. TW 28 is the tare weight. This is a cylinder's weight in pounds when it's empty. 6-92 is the manufacturing date. Cylinders must be retested within 5 years of this date. If it hasn't been retested, then it is dangerous and illegal to refill it. And the FA 123497 is the manufacturer's serial number. And here's an example of the retest stamp. This cylinder was retested in December of 1992 by retester number A123. Cylinder concerns. Always evaluate the cylinder condition before each use. Look for non-condensables in the cylinder, contaminants, deterioration, rupture, leaking. Check the tare weight, looking for traces of oil inside, and clean the cylinder. Cylinder preparation. Determine the type of refrigerant that's already in the cylinder. Recover the refrigerant from the cylinder for reclamation. Compare empty cylinder weight to the tare weight, looking for oils or contaminants. Evacuate the cylinder. Cylinder cleaning may be required if the tare weight indicates there's oil in the cylinder. To remove the oil, recover the refrigerant from the cylinder. Pressurize the cylinder with nitrogen. Tip the cylinder upside down and release the oil through the vapor valve. It is an acceptable practice to remove the valve and clean the tank internally with residue-free solvent. Filling procedures. Recover liquid through the vapor valve and not through the liquid valve. Recovering through the liquid valve may dislodge the internal liquid dip tube in the cylinder. Also, recovering liquid refrigerant into the liquid side will increase the resistance to refrigerant flow into the cylinder. There's an 80% fill float with auto shutoff. Use a filling density calculation if the fill float is not present. Pressure relief and the recovery method, vapor or liquid. To get the safe fill level, take the water capacity of the cylinder times the filling density of the refrigerant. Filling density. This calculation allows technicians to ascertain allowable number of pounds to recover into a recovery cylinder. The goal is to obtain approximately 80% fill levels. Calculate and adjust for refrigerant density. Calculated by dividing the liquid density of the refrigerant at 130 degrees Fahrenheit by the density of water, 62.4 pounds per cubic foot. Then multiplying the result times the water capacity of the recovery cylinder. The recovery cylinder, 100% full of water, would weigh 47.6 pounds. R22 filling density is 1.05. So if we multiplied the 47.6 times the density of 1.05, a recovery bottle 80% full of R22 refrigerant would weigh 50 pounds. R134 filling density is 1.08. So using 47.6 pounds times 1.08 density, a recovery bottle 80% full of R134 would weigh 51 pounds. R410A filling density is 0.88. So 47.6 pounds of water times 0.88 density multiplier means a recovery bottle 80% full of R410A would weigh 42 pounds. Recovery units. Recovery units come in many shapes, sizes, costs, and various capacities. For capacities, vapor recovery only has a slower recovery time, but it recovers no contaminants, high boiling residues, that may be present in the refrigerant. Liquid recovery has a faster recovery time, but it recovers contaminants. Some oil is recovered, acid, moisture. It's also recommended that you recover liquid refrigerant through filter dryers. Here are some reasons that would require refrigerant recovery. Recovery unit, cylinder, tools, and other required equipment are inspected, prepared, and in proper working order. What is the reason for your recovery? Is it a leak in the system? Is it from component failure? Is it a compressor failure? Is it an overcharge? The reason for recovery will impact the recovery method that you use. Recovery due to a system leak. For a leak in the system, Locate and tag the leak location for repair after recovery. Is it possible to isolate the refrigerant within the system? If yes, then minimal recovery is required. If no, then full recovery is required. If the recovery unit is allowed to lower the system pressure into a vacuum, then moisture and non-condensables will be introduced into the system and possibly into the recovery unit and recovery cylinder as well. Recovery due to motor burnout. What is the condition within the system? Oil is still the best indicator of system condition. So check the oil, do an acid test, check the color, clarity, check for water, check for particulate matter. If a burnout has happened, recover refrigerant through filters capable of absorbing the acid, burnout blocks, before the refrigerant enters the recovery unit. This will prevent contaminating the recovery unit and cylinder. A slower option is to recover the refrigerant in vapor form so that no contaminants will be recovered but will remain in the system. Filter dryers. Maintain filter dryers. They clean and protect recovery cylinders, recovery equipment, hoses, and refrigerant. Change the filter dryers when the pressure drop across the dryer becomes excessive. Before and after contaminated system work. Handling. Use refrigeration safety equipment such as glasses, gloves, ventilation, etc. For filter dryer disposal, check state and local regulations. Compressor oils. Handling. Use refrigeration safety equipment such as glasses, gloves, ventilation, etc. Oil analysis can possibly avoid having to change the oil. Some states classify compressor oil as hazardous waste. Deposit in a holding area at the shop and then dispose of properly, such as the local waste management company. Check state and local regulations. External storage. Some things to consider. Contamination. Proper size. Calculate weights. The availability of cylinders. And time. Thank you for joining us for Essential HVAC Principles, Proper Refrigerant Recovery. If you have any questions or need more information, please contact your local Cafferty Group Technical Service Advisors at one of these 12 locations.